what I'd like to do here is give you an example of the glider lab. So in the glider lab, if you'll remember, we had gliders sliding along a nice long air track, and we had a photo gate at one point, and then a glider 1, and we had another glider, glider 2, and for some of them we had another photo gate here, and then for others there was no photo gate. So this is just the general setup. The first thing we did in the lab was we said that we would give a velocity to the first object and figure it out, and then we would find the velocity of the second object and figure it out, and then what we would do is calculate the final velocity of object 1. So in effect what happened was we used the photo gates to calculate the velocity of object 1 initially. Let's just say that the velocity of object 1 initially was 2 meters per second. And we used the photo gates to calculate the velocity of the second object after the collision. Velocity of the second object finally was equal to, let's say, 1.5 meters per second. Now, before the collision, the velocity of 2 before the collision, so velocity 2 initial, was equal to 0 because we had it at rest. So, what we do when we have a problem like this, we're looking for the final velocity of the first glider. So if you'll remember, I tried to show you this method where we essentially draw a picture of a before and after scenario. So before we had glider 1 moving at 2 meters per second. We had glider 2 that was stationary. And then after the collision, we have glider 1 moving with some unknown velocity, and we have glider 2 that is moving at 1.5 meters per second. Okay, at this point what we needed to remember was that the momentum initially equals the momentum finally. And it's important to point out at this point that the momentum initially is the total momentum of this system. So the momentum of object 1 initially and the momentum of object 2 initially. And the momentum finally is the momentum of these two objects put together. So, for the momentum initially, we would do the momentum of 1 initially plus the momentum of 2 initially. And that tells us the total momentum of the system initially. The momentum finally would be the momentum, the momentum of 1 finally plus the momentum of 2 finally. Alright, so at this point what we can do is we can remember that the formula for momentum is P is equal to mv. Okay, momentum 1, initially we would calculate by doing mass of the first one times the velocity of the first one initially, plus the mass of the second one times the velocity of the second one initially. That should equal the mass of the first one, velocity of the first one finally, plus the mass of the second one, velocity of the second one finally. Alright, at this point we're ready to plug in numbers. Now the mass of these gliders initially was 0.3 kilograms. Okay, sorry, that was not right, 0.2 kilograms, right? They were 0.2 kilograms. So now I'm ready to plug it in. So I'm going to go to another page, remember this formula. Okay, so I'm going to plug in the numbers. So let me rewrite it. M1 V1F, my bad, M1 V1I plus M2 V2I equaled M1 V1F plus M2 V2F. Alright, let's remember what everything is. Masses were 0.2. The velocity of the first one initially that I gave you was 2 meters per second. So 2 meters per second plus mass 2, which was 0.2 kilograms, times 0, because it was at rest initially, times 0.2. We don't know the final velocity of the first one, so we're looking for that, plus 0.2 times 1.5 meters per second. Alright, so now we're solving. We need to solve for stuff. So we get 0.2 times 2, and we would get 0.4 kilogram times meter per second, that's the unit for momentum. That goes to 0, so not worried about that, equals 0.2 V1F plus 0.3 kilogram times meter per second. Subtract 0.3 over this side, and we get 0.1 kilogram meter per second equals 0.2 V1F, and then divide by 0.2, and we should get 0.5 meters per second equals V1F. Alright, now I showed every little piece of work you could possibly have in order to solve this problem. I did not, you don't necessarily have to show all of this work, but this is what I would do if you were trying to solve it. Alright, let me show you another scenario. On this case, what let's do is, let's say that we have a same setup. We're on the gliders like we were back here. We have glider 1 and glider 2. Alright, so on glider 1, what we're going to do is we're going to add two 50-gram masses. So we're adding two 50-gram masses. And that's like the number 2. There's two 50-gram masses, not 250-gram masses. Alright, so we added them to the first glider. The second glider is still 0.2 kilograms. If we add two 50-gram masses, the first glider turns into 0.3 kilograms because we've added 100 grams to it. So here we have glider 1, here we have glider 2. Now what we're going to do for the scenario is we're going to keep this one initially at rest. So it will be 0 initially. We're going to throw this one down at 5 meters per second. Okay, after the collision, we're going to measure the velocity of the second one. And let's just say the velocity of the second one, finally, after the collision, is 6 meters per second. What is the velocity of the first one, finally? Okay, so that's what we're going to be looking for. Alright, so let's look at how we draw this. We have object 1, glider 1, comes in at 5 meters per second. Object 2 is at rest, and then we have a collision happen, and we don't know what the velocity of 1 is, and then we know that velocity of 2 is going at 6 meters per second. Okay, so now we're ready to set up our thing. We have momentum initially equals momentum finally. Alright, the way we calculate the momentum is to find the momentum of each object individually and add them together. So we have m1 v1i plus m2 v2i equals the momentum of these two separately, m1 v1f plus m2 v2f. Alright, now we have that set up. We can plug in our numbers. The mass of this guy was 0.3 because we added the masses to it. So 0.3 times 6, not 6, sorry, 0.3 times 5 plus the mass of object 2, which is 0.2, times its velocity, which was 0, equals 0.3 times an unknown velocity plus 0.2 times 6 meters per second. So, now we have this set up. We have 1.5 on this side, that's 0.3 times 5, equals 0.3 v1f plus 1.2. We subtract 1.2 to the other side, minus 1.2, minus 1.2, and we get 0.3 equals 0.3 v1f. Divide by 0.3, and we get that v1f equals 3 meters per second. Okay? And what that means, since it comes out positive, it means it is also going this way. So v1f will be going to the right, just like it was initially. It will just have slowed down. Alright, so this concludes the elastic portion. So in another video, I'll do the inelastic portion. Okay?